We've learnt about reversible reactions, reactions where we take something and we throw it together, and the moment it makes something, it can also form and go the other way. And that's when equilibrium occurs in a reaction, okay? So given that we now understand equilibrium occurs when the rate of the forward reaction equals the rate of the reverse reaction. How quickly we make products is equivalent to how quickly we make reactants. Now this poses a problem because let's say I have nitrogen and I have hydrogen and they come together, they form ammonia. The moment they form ammonia is the same time that they break down and they form nitrogen and hydrogen. That's when equilibrium occurs in the system. So clearly equilibrium is not very useful. So we need to do something in order to ensure that we could disturb an equilibrium. We need to change an equilibrium system. Because what we really want is we want to make ammonia before ammonia can break down and form nitrogen and hydrogen. That's really what we're looking for. Okay? And so how do we do this? That's where Le Chatelier's principle comes in. Le Chatelier or Le Chattelier or whatever you want to call his name, this is where his principle comes in. Now the formal definition says here, if a chemical system at equilibrium experiences a change in concentration or in temperature or in pressure, right, then the equilibrium will shift in order to minimize that change. What does this mean? This helps us. Firstly, it's telling you can disturb an equilibrium. It's telling you that the moment nitrogen and hydrogen come together and they want to break up and form they come together, they form ammonia, and they want to break down and form nitrogen and hydrogen. You can do something to that system in such a way that you can ensure that you can remove, for example, some of that ammonia, right? You want to produce ammonia quicker than what it can break down. And how you do this is by changing either the concentration or the temperature or the pressure of that system. Now, this is the first note you must make. Le Chatelier's principle says, if I'm going to give you an easier wording, so let me just write it down here now. Easier wording for Le Chatelier's principle, okay? Oops, sorry, that's my bad. If a system, and you can write this down in Grave-Neural pattern, if a system in equilibrium is disturbed right, by a change in temperature, pressure, or concentration. Okay, that's just the additional info. The main thing here is that you have disturbed the equilibrium. And these are the only things that can disturb it. Temperature, pressure, concentration, then the system will move in such a way to re-establish equilibrium. Will move in such a way so as to re-establish equilibrium. Okay, that's Le Chatelier's principle. So firstly, equilibrium is established in a system. Then you can change the temperature, right? And you will cause the equilibrium to be disturbed. In other words, you are going to start favoring things. Right. I introduced that word a little bit too early, but we'll continue. And you could change the pressure, you could up the pressure. What Le Chatelier's principle really says is, this is an equilibrium, this is a balance. If I do something to the pressure there, if I increase the pressure, the system wants to decrease the pressure, right? If I increase the temperature, the system wants to decrease the temperature. If I up the concentration of a reactant, the system wants to decrease the concentration of a reactant. That's really what Le Chatelier's principle is all about. Okay, so let's give you a summary set of rules to see how exactly Le Chatelier's principle affects a system. And that's where the word favoring comes in. Okay? So yeah, it says the summary note issued to you documents how these changes affect the system. In other words, how a temperature change will affect the system, how a concentration or pressure change will affect the system. Use these properties together with those of rates of reactions to answer the questions on the activity sheet. Now, I'm going to give you some questions because I have no idea where these questions even are, and I haven't seen the summary note for some years. Okay, right, so let's look at this. Let's look at this in detail. So let's look at, firstly, a change in concentration, right? I'm going to list that over here, concentration. Okay, so what happens with concentration? Well, remember in a reversible reaction, we've already introduced this terminology. You get a forward reaction and you get a reverse reaction. You get a forward reaction, you get a reverse reaction. Okay, so when we favor the forward reaction, it means that we're going to make the products quicker. If we favor something called the reverse reaction, it means we are going to make the reactants quicker. And that's really what favoring is about. It means you're not equal with things. And what are we essentially favoring? We are favoring the rate. We are favoring the rate. So the rules are, if I increase the concentration of any reactant, okay, increase the concentration of any reactant, then I favor what is called the forward reaction. I'm just going to represent it by FR, forward reaction. Well, let's write out the full word for now. Forward reaction. Okay. Now let's deviate from this slightly. Let's decrease the concentration of a reactant. And these are just rules you can memorize for now. If you know the blue ones, automatically you'll know the red ones. I will favor the reverse reaction. Okay. Now similarly, let me look at increasing the concentration of a product. In other words, I throw in more of the products. Then this will favor the reverse reaction. Okay, then if I decrease the concentration of a product, in other words, something on the right hand side of my reaction equation, then I will favor the forward reaction. Okay, so let's look at this. Let's give you an example, and let's say given a reaction that is again nitrogen plus hydrogen gives me ammonia, which is NH3, and let's balance this. That gives me 2 of that and gives me 6 of that, so that's 1:3:2. Okay, so this is a very famous reaction, a very famous reversible reaction, which some will argue is the most innovative thing in the world, and it's possibly true. Let's talk about this. Increasing concentration of reactant favors the forward reaction. Let's assume the system is now in equilibrium. It's a reversible reaction. We've put it in equilibrium, right? Now I tell you, I've added N2 to the system. Okay, I've added N2 to the system. What is the effect thereof? And you have to list it and explain it according to Le Chatelier's principle. Now, what does Le Chatelier's principle say? It says that if you do something to the system wants to do the opposite of what you do. So can you guess, if you add N2 or nitrogen to the system, what does Le Chatelier's principle say about what the system wants to do? It says that the system wants to down it. It wants to decrease it. It wants to bring it down. Okay? Right. So in your case, we've added N2. The effect thereof is the system wants to decrease the value of the nitrogen the nitrogen gas, right? So let's look at this. Let's assume that this is my reversible reaction. Right. The direction of the pen, this direction here, is going to be to the right. To the right, it is going to be the forward reaction. Okay. So when I've increased the concentration, I've increased the concentration here. Right, the system wants to down the concentration. Now, in the effect of downing the concentration, it has to use up more of the hydrogen that it reacts with, and it's going to happen quicker. Now, if it uses up the hydrogen, it means that this is going to decrease. Initially, this will increase because you've added it, but then eventually it will decrease because it's getting used up. And it's also reacting with this, so this also has to decrease. But now, because you've added more of this, you can essentially make more of this on this side. You can make more ammonia. Because I've got more ingredients now, I can therefore make more cakes, right? And that's really what Le Chatelier's principle says. It says, I've increased the nitrogen is essentially going to come down and decrease, and it's going to re-establish equilibrium. And in that process, you will answer a question like this. If I say, we've now added nitrogen gas, what happens to the system? You say, when we added nitrogen gas, okay, let's just write it out in full. An increase, I'm going to write it out shorthand here, in nitrogen, in the concentration of nitrogen gas will favor the forward reaction, FR, according to Le Chatelier's principle. According to Le Chatelier's principle. Okay, so we can say that clearly. Right. Now, what effect will it have? You can continue further. This will result, and this is exactly how you answer a question, in a decrease in both the concentrations of N2 and H2 and an increase in the concentration of NH3 as the system, I'm going to just dictate this part, re-establishes equilibrium, right? The most important, and therefore you will see a higher yield in the concentration of NH3. And this is because when we add more of the reactants, it will favor the forward reaction. Okay. Now, what happens? Let's take that same question and let's change it. What happens if I remove NH3? You can say, Imaad, you're just removing from the products, and therefore you're favoring the forward reaction. And then exactly the same thing happens. Due to a reduction in NH3, the system has to produce less NH3 because we've removed from it, and therefore it will favor the forward reaction. Okay, that's it. It's as simple as these 4 rules when we talk about concentration.